Chapter 11, Sampling Strategies. Sampling belongs to the last level, which is the practical level of research design. The researcher has to decide on who exactly will take part in the study. This is to be done before collecting data. In order to answer the research questions, it is doubtful that researchers should be able to collect data from all cases in a given situation. Therefore, there is a need to select a sample. For example, suppose that the context under examination context contains 500 members. It is not practical to collect data from all these 500 people. The researcher has to select only some of them, but the selection itself is not a random selection. The entire set of cases from which the researcher sample is drawn is called the population. Since researchers neither have time nor the resources to analyze the entire population, this is impossible, so they apply sampling techniques. Consequently, a smaller group, which is the sample, must be selected, and generalizations of findings about the larger population can be made by studying that. Sampling involves determining and selecting the circle of those to be observed, to be studied. We present here some key definitions of key terms. We have seen that the sample means that all the elements who are really involved in the study, while the population involves the entirety of these people. For example, a researcher is interested in studying intrinsic motivation among second-year students of English. In that case, the population is or includes all the students who are enrolled at the second-year level. The sample means those who are selected among the second-year students. This may be, for instance, one group or two groups or a number, but not the total number. The sample includes the elements which constitute the basic units about which information is collected, and they serve as the basis of the analysis. Suppose that the researcher wants to administer a questionnaire to a sample, so the information is collected from a limited number. The elements of a sample are usually people, but they can also be things. This depends on the study itself. The population is the theoretically determined totality of elements to be examined. For example, the persons or things that suit the previously defined selection criteria, and that conclusions are to be made about. In our previous example, the population is the second-year students of English in general. We have another term which is the target population. Here, this is a narrower circle, meaning all the persons or things of whom or which the actual sample is taken. For example, second-year students of English at Qasdi Marbah University. Now, the term sampling means selecting participants. This is the practical level. Sampling has to ensure that the sample represents the population. Representativeness means that the collective characteristics or the properties and the parameters of the sample approximate, they are close, the same total characteristics of the population well. We take an example. Suppose that a researcher or someone wants to have a makeup session. A teacher wants to have a makeup session on a fixed date, and he seeks the opinions of the students. Do you think that Saturday is appropriate for this makeup session? The teacher now has to know about the opinions of the whole class. Suppose that the teacher asks 2 students and they give certain opinions, and on the basis of that he will say that these are the opinions of the whole class. Now we have to ensure the sampling, the selection of the sample. Those people who were really asked should really represent the opinions of the whole class. This is what we mean by representativeness. A sample does not need to be representative in every aspect. It suffices if it is limited to the characteristics important for the specific research. At this level, we have distinguished between the term sample, the term population, and the term target population, representativeness, and sampling. An exceptional case is when it is possible to investigate the whole population. In that case, we talk of a total investigation. In that case, sampling is not relevant. The results of such studies clearly and reliably describe the characteristics of the population examined. Types of sampling. Sampling procedures, or the selection procedures, can be classified into 2 groups fundamentally. 2 types of sampling: random sampling and non-random sampling. We should be careful here concerning the meaning of the word random. It is not the literal meaning of the word random that we find in a dictionary, but the term random and non-random are technical terms in research methodology. So let's try to discover what is meant by random and non-random sampling. Before doing that, we can say that in general, random sampling is better than non-random sampling, but non-random sampling is easier. Firstly, random sampling. This is also called probability sampling. Probability sampling means that every item in the population has an equal chance of being selected. The sample which is selected represents the population sufficiently. Consequently, the statistical conclusions drawn can be considered well-founded. So this type of sampling leads to valid findings. In research, one should try to use probability sampling techniques. The key benefit of probability sampling methods is that they guarantee that the sample chosen is representative of the population. That's why they are better. Now, the second type, which is non-probability sampling or non-random sampling, here we do not know the probability that each item will be chosen. A sample of participants or cases does not need to be random, but a clear justification is needed for the inclusion of some cases or individuals rather than others. So there is no randomization here. Non-probability samples cannot guarantee representativeness. This is their weakness. Thus, conclusions drawn from them are limited. Individual elements have smaller or greater chances of being included in the sample. Non-probability sampling methods offer 2 potential advantages: convenience and cost. They are easier and less expensive. The main disadvantage of this type of sampling is that these methods do not allow you to estimate the extent to which Sample statistics, the findings that you find in your sample, are likely to differ from the population. The main types of probability sampling strategies are simple random sampling, stratified sampling, cluster sampling, multi-stage sampling, systematic random sampling. Simple random sampling refers to any sampling method that has the following characteristics. The population consists of a number of objects, capital N. The sample consists of another number of objects, small n. If all possible samples of small n objects are equally likely to occur or to be selected, the sampling method is called simple random sampling. It means that every member of the sample has equal chances of being selected. There are many ways to obtain a simple random sample. One way would be the lottery method. Each of the number of members of the population is assigned a unique number. Then the numbers are placed in a bowl and thoroughly mixed. Then a blindfolded researcher selects numbers for the sample. The second type of probability sampling methods is called stratified sampling. With stratified sampling, the whole population is divided into groups. These groups must be homogeneous. It means the internal structure of each group should be homogeneous. For example, a class of students consisting of members of different nationalities. So the groups, the division of the groups would be according to the nationality. Within each subgroup, all the members have the same nationality. This is just a clarification example. Then within each group, a probability sample, often a simple random sample, is selected. So we conduct simple random sampling within each subgroup. In stratified sampling, the groups are called strata, and hence the name stratified. The third type of probability sampling methods is called cluster sampling. With cluster sampling, every member of the population is assigned to one and only one group. Each group is called a cluster. Here the groups are not homogeneous. Then some clusters are chosen. It means a sample of clusters is chosen. The technique is simple random sampling. Only individuals within sampled clusters are surveyed. So the selection here, if we compare this type with stratified sampling, we select groups rather than individuals. With stratified sampling, the sample includes elements from each stratum, members, individuals. With cluster sampling, in contrast, the sample includes elements only from sampled clusters. So the selection is selection of groups rather than selection of individuals, as I said. The fourth type of probability sampling methods is called the multi-stage sampling. From its name, we understand that it follows stages. Stage 1, then stage 2, for example. With multiple stage sampling, we select a sample by using a combination of different sampling methods. We combine some of the previously explained sampling methods. We take an illustration. For example, in stage 1, we might use cluster sampling to choose clusters from a population. Then in stage 2, we might use simple random sampling to select a subset of elements from each chosen cluster for the final sample. The last type of probability sampling strategies is systematic random sampling. With this type of sampling, we create a list of every member of the population, for example, from 1 to 100. From the list, we randomly select the first sample element from the first k elements on the population list. Thereafter, we select every kth element on the list. This method is different from simple random sampling, since every possible sample of n elements is not equally likely. You see in the example, the members of the list are listed from 1 to 100. Then we have to determine the sample size. For example, we would like to take 20 members. We have to divide 100 by 20 and we get 5. In that case, k is 5. Then we have to select every fifth element from our list. Non-probability sampling strategies. Here we have 5 types: voluntary sampling, convenience sampling, purposive sampling, snowball sampling, and quota sampling. The first one, a voluntary sample. This kind of sample is made up of people who self-select. They are volunteers into the survey. Often these people have a strong interest in the main topic of the survey, so they choose themselves. The second kind is called convenience or accidental sampling. A convenience sample is made up of people who are easy to reach, subjects easily available for the research. In other words, those subjects whom you can find easily. The third type, which is purposive or purposeful sample, here the researcher knows subjects with which qualities they need and they look for those. So here the sample consists of individuals who have certain characteristics that the researcher is looking for. If the characteristics are present, so the person is chosen. This method is mostly used in qualitative research. For example, a researcher is looking for teachers of English who have taught writing to first-year students. So the most appropriate method of selecting the sample is purposive in that case. The fourth type, snowball sampling, is applicable if defining the members of the population is difficult. For example, homeless people or migrants. It's not easy for the researcher to find them. The researcher collects data from some people that they can find in the population examined, those that they know. And then he or she asks these selected people for the contact details of acquaintances belonging to the population, other people like them. So the population, the sample here grows gradually. The word snowball refers to gradual growth. The gradual growth of the sample itself. It grows little by little. People contacted suggest further people and so on. It is used for exploratory purposes primarily. The last type of non-probability sampling strategies is quota sampling. This is the non-random method of stratified random sampling mentioned earlier. The population is divided into subgroups. These might be even proportional, having the same size, from which, however, elements are not chosen randomly. In that case, the selection of members does not follow simple random sampling. It is a more reliable procedure than simple non-random sampling, but it does not guarantee representativeness. On the whole, we can say that non-probability sampling strategies are possible. They can be used by researchers, but they do not guarantee representativeness, as it is the case with probability sampling strategies.